Our battery systems are such that the zinc is the fuel and the battery is kind of the engine. If I were to draw an analogy with a diesel generator or simple IC engines that we use. Now, if it could be the applications could be disaster management. You want a mobile power at any location that will give you, so that you are at a remote location. You could take these zinc plates, put the battery there. It could be on a vehicle, dump it inside, and it will give you power immediately. That is one. You could have far off places where the infrastructure projects are going on, the railroads are going on. There all the power is being generated by diesel generators. So we could actually act as a green replacement to that. Beyond this, the major application is on the grid side.
Hello and welcome to another episode of Speciale Focus, brought to you by Speciale Invest, a leading early stage deep tech VC firm in India. I'm Hari, and in this episode, I bring you a conversation with Gunjan Kapadia, Akhil Kongara, and Muhammed Hamdan, co-founders of Sthyr Energy, who are developing a novel long-term energy storage solution that could play an important role in India's transition to an economy led by renewable energy. In a world racing to electrify everything, one bottleneck keeps reappearing: how to store vast amounts of renewable energy cheaply, safely, and for long periods of time. Lithium-ion batteries, the workhorse of today's energy transition, were never designed to shoulder the burden of seasonal storage, back up islanded grids, or replace diesel generators on remote military bases and infrastructure projects. At Sthyr Energy, the founders, who are all researchers at the Indian Institute of Technology, Madras, are betting that the answer lies not in more lithium, but in a humble metal that India already knows well: zinc. They've set themselves an ambitious goal: to build zinc air batteries that can store energy for months as dense zinc plates without the steady self-discharge that plagues conventional batteries. Their design separates the fuel, which is zinc, from the battery stack, enabling long duration storage, container scale energy shipping, and automated zinc replacement, while aiming for lifetimes that match solar and wind assets rather than today's short lived battery packs. In this episode, Gunjan, Akhil, and Hamdan talk about how they zeroed in on the idea of long duration storage, the science behind their patents, and what it will take to make India's own grid scale battery technology that we might one day depend on. Gunjan, Akhil, Hamdan, welcome to the Speciale Focus podcast. Maybe you all could give us a quick snapshot backgrounder on how you started Sthyr Energy. Give us a glimpse into some of the conversations, brainstorming that went into it, leading up to starting this company. What was the problem that you were tackling, or what was the innovations that you were all discussing and as a potential opportunity? And let's go from there.
So, uh, one as a company, Sthyr Energy was formed in 2024. But company is just a company, right? It's more of an idea when you have actually started thinking about startup and when you actually want to build the product. That started way back in 2019 and 2018. The idea when me and Akhil, I joined after Akhil in for PhD at IIT Madras, and I mean 6 months after him. But when we joined, we had this idea to have a startup, to have a product which could lead to a startup. So that was the idea, and that is when it spawned. It started one. Secondly, as you said, what were our thoughts? So there were a lot of journey was involved into it. Our Professor Arvind Kumar Chandiran, who was involved from the start with this, has also helped us or understand us what is the market need. So when we actually are looking for to build something, we never went say that, oh, I know this, then I'll build this. So it could be like I'm an expert in this domain. It could be in electrochemistry, it could be materials, it could be anything. Then we did not jump into, since I'm an expert in this, we would build a product or we'll build a company out of it. That was not the thought process. From the start itself, the thought process was to see what is the market need today and in future, and is there a gap that we could see in that market need, and then do we have the expertise to build something for that. So we had talked to a lot of people, we had spoken to probably almost all the OEMs in India, understood what they need to some extent, what is their requirement in terms of energy storage, and then try to figure out solutions. Then we looked into the market. What are the current available technologies and what are their pros and cons? What are their advantages? What are their disadvantages? And what we could work with. The other framework we looked into, do we have IP space for whichever domain we are working in? And one more point is it safe? And can we make it in India? At low cost, the materials are available, the supply chain is stable. So we had all these pointers put into a spider chart and then evaluated each technology that we should work on. And after evaluating, we came up that for a certain application that we are targeting, zinc air fits better. And that is when there was always the thought to go to the startup, and that is when it started.
Yeah, as Gunjan said, we started back in 2018 with an idea, and of course, we didn't jump into the conclusion that we can do everything. But of course, we took a lot of pivots before we even started this company since 2019. So we started with an idea that we want to build these batteries for EVs, electric vehicles. Uh, for almost 2 years, we were only focused on electric vehicles as our applications. We did a lot of background study. We talked to a lot of industries to see really that this battery is fitting in that application. And there was a point when we realized, okay, there are some constraints that we cannot get into EVs. We decided that okay, let's go and find some better applications where we are genuinely fitting. So this way, in fact, me, Hamdan and Gunjan had a lot of brainstorming sessions to really see we are going in the right direction, and both as a technology and as a use case or the application that we are looking at. So yeah, as a team, we are much older than the company. We did a lot of brainstormings, took a lot of turning decisions, and which shaped what we are today.
So Gunjan and Akhil, they started working on zinc air batteries from 1819, but mine was a slightly different part. So we all three are from IIT Madras, PhDs from IIT Madras, worked under same professor, Professor Aravind Kumar Chandiran, and even like Gunjan and Akhil were working on zinc air batteries. I was in a different field. I work on hydrogen-based systems. So I was developing catalyst for water splitting. Basically it will generate green hydrogen which can be utilized as fuel. So that was I was more into the fundamental, and then I was also part of this microgrid. So we were building microgrids, like our own buildings we were taking as a test rig, and then running these buildings with like batteries and hydrogen. So there also we were combo every time. So I was not part of zinc air batteries from the start, but like around 2023 2020, like 2023 end was when I was part of zinc air battery. But all three were together for like 6 to 7 years. Yeah. So
Yeah, it's very interesting to see that sort of hardcore technology trio is forming the founders group, and it will be fascinating for me as a journalist to see how you all will evolve on the business side in the coming years.
As you said, we are all deep technical people, but as people, we are very different. All three of us have different characteristics. In fact, at Special, we did that analysis also, saying that what qualities you have, and you do take some tests, psychometric tests, and do all of that. We did that, and even in those tests, and we understand this beforehand, that my way of working, Hamdan's way of working, Akhil's way of working and thinking all together is completely different. So I have done my MTech way back in 2011, 2012. That was at IIT Madras. But then I had a break. I had worked in industry for 1 and 2 years, and then came back and did have my own business for 6 years. And then after that, I joined for a PhD. The very reason of joining the PhD is to build a deep tech product. When I say a deep tech product, there are certain challenges which has to be solved by science or engineering. It cannot be solved by business, and to build something. So that was the idea when I joined and Akhil joined the PhD. So giving you at the same time, I have a bit of business mindset. I'm fairly aggressive. I try to look at overall things. Whereas Akhil, if you look at, Akhil is fairly very, very focused. So if you give him one task, he'll go in the depth of it and understanding. So we could form that T, right? So one is have an overarching view of things. At the same time, you should have the depth also. And Hamdan is an amazing worker, very, very smart. I mean, one of the smartest person I've known, and completely a team player. Very good with managing people. That me and Akhil are fairly bit on the lower side. So that's a very interesting combo. So when people look at us, they think, "Oh, three PhDs. How could they do business?" But the other side of it is we are completely different people. We understand what our strengths are, and we understand who can do better in what, and then we try to do that.
So my perspective is PhD is just a medium for us to build the product. In fact, as Gunjan said, we both were MTechs in IIT Madras itself, and both of us, like Gunjan, went out and did a lot of his own work, and even I got a job before even completing my MTech. But honestly, what was driving us is to do something meaningful, and none of the jobs we are doing are really helping us to satisfy our curiosity or the drive to do something. So that is when we are kept in this situation to keep searching for something that we can do meaningful. And this is where our professor really came in and helped us, saying that see, I will, if he always says that what technology is being developed in India that is used by the world, so that's what the kind of thinking he had. And then we also felt, okay, this is where we should really do something. What can we do in India? What can we build in India that's really you can be used for the whole world, right? This was the kind of standards our professor used to set in thinking. And like as we keep discussions, and we used to discuss 100 ideas. But once when we were discussing with automobile companies, this was back in 2018, they said we are depending on China for batteries. Why no one is doing something in India? that question is what triggered us, saying that being chemical engineers, can we build something? Can we build a new technology in India that can be used in EVs? Why should we depend on China? So that's how our curiosity started. And none of us honestly had a intention to get a PhD. We didn't join PhD because of intention to get a degree. Rather, it was this question saying that can we build something, which have driven us. And as I said, professor and we joining in PhD is a medium for us to build this technology. So we always have seen our PhD journey like that. So typically in IIT's, PhD goes for max 4 to 5 years. But as I said, we are there since 2019. It's almost 6 years, and we are not really worried about how much time we are spending, but we only focus on what exactly we are building and is it meaningful.
So let's talk about your company itself, Sthyr Energy. I mean, from the name, one can guess a little bit because of the meaning. I mean, correct me if I'm wrong. It's probably means still or stable and so on. in Hindi or maybe Sanskrit. But can you briefly talk about how you thought of this name and why that's relevant for the technology and solution you're building?
Sure. So the name is a philosophy. People, as you rightly mentioned, it does represent the term stable, but that stable doesn't represent. I mean, it does represent our product to get stable output power from a system. That is one. But we had actually, in fact, we have even before forming the company, we had formed this constitution for the company, which you could say a handbook kind of thing, where we had written few things before, say that how the company should be, what should be the goal of the company, how it should work, and we had read few books. One of the books that had inspired me was Good to Great, and there it was mentioned that what you're looking to build. So for that, we always had this mindset of the company's growth has to be stable. When you look at the startups in India today, I mean that's saying that we look behind what we are building now, or we look behind valuation and not actually substantial uh, products that is to be built and have a long term company built. You look at immediate growth, exponential growth, and then that growth may grow down and you die down. We actually want to build a company which is the philosophy is to build stable businesses for longer period of time,
It's
and
like built
that's
to
what
last.
yeah, sorry.
Built to last.
Yeah, so basically, we want to build something to last, and for that, we understood that the growth has to be stable, sustainable, both in terms of scale, in terms of business, in terms of product. So that's why the name's there. That's a philosophy that we have at the company.
Okay. Can you also give us a layperson's understanding of the technology and the first product that you all are looking to develop?
So say that our major challenges are coming today because we are moving towards renewables more and more. So as we increase our renewables more and more, our dependency on energy storages would increase. That is one point to be noted. So basically, you have to store energy for longer time because you have intermittency, which is variation in solar generation and variation in wind generation, which could be say that during the daytime you have solar, but in the night time you don't have solar. So for that time, you have to depend on energy storage. This is one. But also, your variations are monthly and seasonal, which is you would generate wind in, say that in a year, if you look at the total energy generated, you will generate only, I mean, 4 or 5 months will generate a total years of energy for windmills, right? So basically, it's very eccentric. It's located in one direction. One like few months you'll generate more, few months there'll be lagging period. You would not generate. In this case, you have to store this energy for longer period of time for seasons. Correct. Now, this is what we build. We store the energy in the form of metallic zinc. If I take a zinc plate, we store the energy. So, zinc is our carrier, energy carrier. So, in one season, you have more energy than that is required. In another season, you have less energy than that is required. So, you have to actually move that energy from one. So, what we are trying to do today is we are trying to move the energy from day to night. Store it in the daytime, use it in the night time. Other part of it is you have to store it in one season and utilize it in the other season. And that is what exactly we do. Store it in the form of zinc plates, put it into the zinc air battery. So zinc and oxygen from the atmosphere, basically air reacts and you get the energy back. So in basic terms, this is what we do.
There are a lot of applications where seasonal storage are required. So basically, for example, for our case, the thing will be certain defense application we can utilize. So typically now whatever happens is that this long duration energy storage, there are actually long duration, you can put it as like on the basis of hours you can put it. So there are 8 to 10 hours of storage typically people say. These are kind of batteries like redox flow batteries will come in, but when you look into the storage part, there are not much battery technologies there. So that's where the zinc air battery technologies are going to come up, and the applications typically will go to defense applications, islands. So wherever countries which has very high rate, or places where there is more renewable energy percentages. So these are the places it will be coming to.
What we mean by seasonal storage, or what the application, what Hamdan meant is, say that you are at an island and you don't have grid connection, you don't have EB power at your place. So now at that point, what you have to do is you have to store the energy in the daytime and use it at the night time. But say that if it rains for 3 days or if it rains for 1 week and you don't have solar at all, so then what do? You have to be dependent on either on diesel generator, or if you don't have diesel, you're out of power. So you don't get, so solar energy is not the concern. The reliability of power from that is the concern. So the application that we target is islanded applications, which could be, say that we have a military base in Leh Ladakh. It is generating its own energy, but certain period of points it has energy storage also. But then certain times you have to use diesel generators to get the reliability. And that diesel generator, which is not green and also expensive, we could replace both. So these systems would be more green and less expensive. So we could have the reliability of a diesel generator and a green source. So that is the major challenge. You don't have the reliability of the actual conventional sources. So one is the diesel, the other is one. The other is, it could be a data center. We have diesel generators as power backup in data centers. We could have zinc air batteries in place of diesel generators in that. So it could act as a DG thing. Other part is our battery systems are such that the zinc is the fuel and the battery is kind of the engine. If I were to draw an analogy with a diesel generator or simple IC engines that we use, you have fuel, you have engine. The zinc is the fuel, engine is the battery. Now, if it could be, the applications could be disaster management. You want a mobile power at any location that will give you, so that you are at a remote location. You could take these zinc plates, put the battery there. It could be on a vehicle. You dump it inside and it will give you power immediately. That is one. You could have far off places where the infrastructure projects are going on. The railroads are going on. There all the power is being generated by diesel generators. So we could actually act as a green replacement to that. So these are the applications which people would understand. But beyond this, the major application is on the grid side, which is on the utility scale. When I say the utility scale, you have thermal power plants, and then you have a distribution system or a power grid, then it goes to discoms, and it's distributed to the users eventually, the power. Today, our thermal power plants are operating at the total energy we get from India's total energy that is required, so that 700 terawatt hour. We typically get 85% energy from the thermal power plants, because thermal power plants give a very flat, or it's 24-hour operation, and it could give you power, stable power output anytime. But as we keep increasing our renewable energy, which is more solar, so government of India has this 500 gigawatt of thing target, and in future it's going to go up and up. So when you go to 2035, our grid would be more solar, more wind. Then the variations would start affecting, and that is when you would need energy storages at the utility scale, at the grid scale, to get stable power output to all the people. It could be industries, it could be local consumers. So that would be needed at the grid scale. These batteries could be used for industrial applications also today. So,
Can you talk a bit about your first product? Just give us a sense of the type of capacity you're looking to develop, and initially a sense of the type of infrastructure that it can power, and for how long in the specific case of this product, and so on.
I'll take one part of that question, and then Akhil Hamdan can give you more details on what is the product size and how long and all. So if it is, say that we have to look at scale. So when we look at a power application for defense or for industrial applications, which is CNI, we kind of look at 10 kilowatt, 100 kilowatt, and then beyond going to 1 megawatt scale. But if you go to a data center or if you go to a grid utility scale, your scales of power, which is I just now mentioned, kilowatt to megawatt to gigawatt, you have to go up. So today we are in the kilowatt range, building our product, which would go to certain applications that we are targeting. And then we have to validate that product, test that product. And then once that is done, we would go to another scale, because when we say different applications, each application has a different power requirement, different scale of it. So even to test it in that environment or that application, we have to build that scale that we are going to do in a stepwise manner.
Whatever we are doing for the first thing, it's going to be at 5 kilowatt scale. We are now into the product development side, and it's very important for us to validate the product before it goes to the market. So the validation has to be done in a smaller scale. So that's the reason why we are putting it at a 5 kilowatt system. Once the validation has been done, these systems are like modular. So you can just put 3-4 numbers of the systems and then make it to 20 kilowatt, 30 kilowatt. So first thing is the validation part, and that's what we are doing for a 5 kilowatt system.
So today, can you give us a sense of where you are at? And of course, there are so many variables, but a rough sense of what kind of timetables you're looking at in terms of having a commercial product in the market.
So if you look at the numbers, if you ask for a timeline, so the 5 kilowatt system is going to be coming for by April. We'll have this product 5 kilowatt system, and the thing is, as I said, the validation is very important part. So, and we are talking about cross seasonal storage, which basically means that you have to do the validation at different seasons. So the product is going to be around April, it will be there, but then again for 1 year it has to be tested, and that after 1.5 years is typically it can go to the market side.
So one is we are building this product, but these products also have to be tested at different use cases. Or so once we build this in by April, we have partnerships with few companies which are going to be tested for different use cases. It could be sub-zero temperature. So when you go to Siachen or when you go to Europe, your temperatures are going to go at minus 40 degrees, where no other batteries work. Our batteries would work there. So we are going to test that use case at a company. We are going to use 100% renewable energy or net zero system at one company. So these are the 2-3 different use cases. At the same time, parallelly we'll test all of that, and that would happen in probably 1.5 years of time from now. Once we reach that stage, we again would scale up. Scaling up is more of an engineering or system integration part. But then now we are say that whatever Hamdan is mentioning is at a kilowatt scale, then we'll go to hundreds of kilowatt scale or a megawatt scale as a next step. And that would take us say that around 2.5-3 years from now. Once we do that, that is when the applications come in for data centers and for grid and utility.
And specific to your product, anything that comes to your mind in terms of innovations in any area, whether it is the end manufacturability of the product or materials that you are using or the way you have designed the battery, and anything that comes to your mind in terms of innovations that we can highlight.
Yep. So there are. So I will start with the question that you asked. What is the first product it going to look like? Multiple things came to my mind. For me, there are a lot of firsts in last few years. So the first small cell that we made, first electrode that we made, and since then, what you are asking now is what are the technological breakthroughs or innovations happened, right? So I would say like almost every 6 months we are seeing a breakthrough in solving some new problem, and in that sense, today whatever we are saying, right? We are able to store energy for a long time, seasonal storage. So that and combination with high energy density, like longer time of discharge. So this is to say it is simple, but on a technology point of view, it's a lot of work and a serious innovation that happened before, right? So that's what I will keep so close to my heart right now. Is like how did we try to utilize more zinc in a given time without failing. So I don't know if I can go more into the details, but that is one of the innovation that we breakthrough we had in last 2 years. And the way I see how we are going now, and most probably we will be, in next 4 to 6 months we will be uh, doing one more breakthrough in the performance side. Performance in the sense how much power we are going to unlock from the from a given size of battery. I see a great potential that we are going to unlock a great innovation or breakthrough there.
Yeah, actually, it would be interesting, Akhil, if you can, the idea of using more zinc. I mean, people probably would be curious about what is the significance of that and what is the innovation or breakthrough that you have achieved here.
Correct. So I won't go too much into technicals, but I will try to put it in such a way that people understand what that means. Um, so first, if I want to store energy for season, from summer to winter or something like that, and at a very low cost, cost for me is space. So I need small space, but I need to store a lot of energy in that small space, which means I have to store energy only in the form of a zinc plate, right? I don't want to store the whole battery. So this is a new revelation that we had in the starting when we thought of doing seasonal energy storage. Uh, but the challenges are multiple here. One, we have to store energy in the form of thick zinc plates, right? And these thick zinc plates, when they have to be discharged in the battery, we have to consume all the zinc that we are putting into the battery. It's like saying, um, if I'm putting 10 liters of diesel into a vehicle, I would obviously expect that 10 liters to be consumed well, efficiently. I don't want to lose 5 liters in between in some way, right? So similarly in zinc air battery also, zinc is my fuel, and no matter how much zinc I'm putting, everything should be utilized as much as possible. Now there are challenges, technical challenges, like it will be lost due to corrosion, it will be lost due to dead zinc, they call, like it will be blocked with some different layers that won't allow the zinc to react further. So these are the typical challenges a thicker zinc anode will face. And the breakthrough that we are talking about is how do we design the whole cell, and then how do we ensure the whole flow that is happening in the electrolyte flow happening, such that no matter how much thick zinc plate I put, I will be able to consume it more than 95%, right? So and it's really a great breakthrough that we can say that today we are confidently saying to everyone that I can give you continuously 100 hours of discharge without stopping. Now that confidence came from this breakthrough.
Today, when you say energy cannot be stored for a longer period of time, you take your mobile phone, charge it today, and try to use it after 6 months you have not used your phone, but you come back and see that after 6 months, the energy would be lost during that time, right? And that is one of the challenge, which is called a self-discharge of the battery. So we don't want to do that. So when we are storing for longer period of time, we don't want to have that decay of energy over a period of time. And that is one of the major breakthrough. That is what Akhil is mentioning. Say that I could store energy in this zinc plate without decay. So we don't store energy internally into the battery, we store it externally. So this is where our major difference between any tech that you see globally. We store externally the energy, and that is what allows us to store it for longer period of time. One. Second is the zinc itself is very, very energy dense, which means that I can store a lot of energy in very little space, what Akhil is mentioning. How is this advantageous is you were to ship, say that now there's a case where you are generating solar at one location. That is the case in India also today. You generate solar at one location, but your discharge or usage, the people or the industry are at a different location. So you supply that by the grid. But there are cases if you're generating offshore, which is far away from the main line, then you have to put up a very huge grid line, a transmission line for that, right? Instead, You could supply zinc plates alone. So you generate zinc plate at the solar farm or wind farm, and then supply the zinc, and at another location where the usage is there, you have your zinc air battery. And the zinc battery could, I mean, zinc plate would go into the battery and it would give you power. Now, why very specifically zinc is low cost. One, second, there's no decay over time. Third, it is very, very energy dense. So in a container, you can visualize a container of 20 feet. You could almost transport 18 megawatt of energy, megawatt hour of energy. So that's a huge number. If I were to put only lithium-ion batteries into it, you'll only transport 1 megawatt hour of energy. So this difference in energy densities and how do we design the system. So there are multiple innovations that we put in to actually go to the products. And the other thing is the lifetime of the batteries. Will these batteries work for a longer period of time? That is another challenge that we have solved. So there are a few breakthroughs in different sections that we have achieved to actually form a single product.
Okay, if you were to summarize a brief list of what are the innovations that are proprietary to your work or to your company, can you quickly walk us through that?
So the battery design that we do is proprietary to us. There is the electrode that we make. We manufacture ourselves, and that again proprietary to us. What Akhil was mentioning, how do I generate zinc from zinc oxide, right? So that is again the designs are proprietary to us. So we have 4 or 5 patents now. One is a component of a battery, the other is a component of another system in a battery, and then the overall system. So all these things are proprietary to us, and very specifically, our two very unique things or USPs are the gas diffusion electrodes or the electrodes that we make for these batteries, and the other side of it is the zinc recharging or zinc plating systems that we make for dense plating of zinc. So these two are very unique to us globally.
Okay. Beyond the 5 kilowatt battery, the first product, is it possible to give us a sense of what you're looking to target in the next iterations or the next variants of your product?
So we are targeting various applications, and those various applications require different scales. Also, we have not talked about how these batteries work. Let me just give you a brief, and then that would give you a bit of context. So say that you have excess energy, you have power now that you want to store it. What we do is we convert zinc oxide to zinc plates and get thick zinc plates out of it. So this is my energy storage. This is one side of the charge. So this is my charging system. Other side of the system is the battery. I take the zinc plates, put it into the battery, and it would give me zinc and oxygen from the atmosphere would react, and you'll get the zinc oxide back. We use the same zinc oxide. So it's a completely circular process. We convert zinc oxide to zinc back to zinc oxide, and use the same zinc oxide to convert back to zinc plates. Keeping this in mind, we have to build automation for this. We have to build our battery management systems for this. We have to do system integration, system engineering for this. So when we go to scale, we have to build automations, logistics for zinc, and logistics plus automation. How do I say that do the zinc replacement? And that's when you ask, can you use it for a smaller people or household systems? At this point, we would say no, because you have to have these automations in which you need to replace those zinc plates. But at a larger scale, that is much more feasible. So it could be industrial scale or things like that where we could utilize this system. So that's why we think 5 kilowatt or 10 kilowatt is the minimum scale that we'll test it today. But eventually the scale that we look at is megawatt and gigawatt. So our whole target is to have gigawatt scale of systems, which is on utility. Saying that you visualize a world which is net zero, and to achieve net zero plus reliability. So that reliability part comes with our systems, and that is when we build. If we have gigawatt scale of systems, that is when we could do that.
Okay. One thing that's not very clear in my mind is currently, does your product require the users to manually insert or put in the zinc plates?
The scale that we are building now by April, no. we are building automation. So there'll be a automatic replacement system, a smart system, which would know when to replace, when to remove, and all of that. It's a plug and play system. You don't need to do anything. The system works like the zinc is being replaced, but the person does not have to do it manually.
So it's like automation. There will be automation, which there will be hands, robotic hands, kind of, which will come, pick and place wherever we want.
Yeah, in fact, that was kind of where I was going, and I was thinking maybe that's not correct. But since you mentioned it, I was actually thinking whether this is an area where robotics-based automation is relevant, and today is sort of off-the-shelf tech available for you guys to use robotic arms like that, or do you need to build your own for your applications?
Yeah, so the thing is, when you look into the automation part, one thing you have to look about is when you say robotic arms, to look into the cost. So basically, if I have this 5 kilowatt system, my automation cost should not be more than 10%. Whereas for so robotic can, even though we talk about robotic, it may not be suited. But there are other systems like gantry systems which can be utilized and then which can be low cost. So it's not just the robotic thing we are looking into. We are looking into a low cost automation solution. But then the thing here is we have to ensure that there is less manual intervention to it. So no one has to be there. It will automatically, once the plate is uh, ready, we'll get the signal from the BMS and the plates will be taken out automatically by the automation systems.
I want to ask a couple of questions on your startup experience so far. You mentioned that you made some pivots earlier on. Along with that, can you give us a sense of what were some of the things that you needed to solve by the time you arrived at the Zinc Air battery as the product that you want to build, and even after that, both on the business operations side as well as working backwards from that, the things that you needed to solve in your product? Can you give us a sense of what kind of entrepreneurial challenges you faced?
Let us first look at the product and then look at the entrepreneurial challenges. So when we see a product, and that too at a utility scale or energy systems, we look at systems which are very, very robust, uh, and they have to survive for 15, 20 years of your, so you get solar panels which are 25 years of lifetime, wind farms which are 30, 35 years of lifetime. Similarly, our energy systems are not so robust. A battery would fail in 3 to 5 years of time. What we aim to do is build very robust batteries that would stay for longer period of time. One. Second is in terms of, so what is the challenge in this? The challenge itself is saying that how do we build a very stable or long-term battery and improve the lifetime of the battery. So that has been a great technical challenge for us, that we are able to solve it to some extent, and we plan to improve it further and further as we move along in the journey. Secondly, entrepreneurially, I think it was never a question for us that difficult. I mean, I don't know. This may be my very personal opinion, but uh, I did not find this challenging at all. We actually enjoyed it. A lot of this thing in terms of building, raising funds, and a lot of things happened quickly also. So we did not struggle to get grants from government of India, or we did not struggle to raise our funds. We are very lucky with our people who we are working with, our employees. We are very lucky with them also. Only thing I think in the entrepreneurial challenge, if at all I were to put it, and since we have a manufacturing unit in Chennai now, and we are building these batteries, just to getting things done on time, and that is not the technical part. That is the non-technical part, which is probably on the compliance side or the fabrication side. I think that is one challenge that we faced in our entrepreneurial journey. Other than that, it was fairly smooth for us till now. So I think I'll put a caveat to it and say, yeah.
And in the long run, do you Are you looking at manufacturing batteries on your own at your own factory?
We do that now here.
Right. So, I mean, say 3, 5 years down the line, when you have much more scale, at that point, is it important for you to have your own factory, or is it perfectly fine to have a contract manufacturer? I mean, in your case, how would that work?
So the very critical component, that is the gas diffusion electrode and the R&D, would be, when I say R&D, it's not actual R&D, it is like testing and all, would be with us. So today also we do contract manufacturing for the assembly, for the engineering, for the making the casings and cells and contacts and all of that. What we manufacture and assemble is the gas diffusion electrode in our facility, which is very, very critical. And even at scale, we would keep doing that. And that is one of the challenge we envision. So when you scale a battery, these are electrochemical systems, which is quite different from a mechanical system. So if you build a smaller system, say that, which is a mechanical device, you could scale it up without much of challenge. But if it's an electrochemical system, when you scale it up and when you want to even increase your production capacity or increase the scale of the production, in both the cases, you will not get the same performance. So we have to do that on our own, even in future, but the contract manufacturing, all the other engineering aspects of it would be obviously contractually manufactured. But very specifically, the gas diffusion electrodes, our electrodes will manufacture on our own and assemble themselves.
Okay. Over the next 18 months, 2 years, of course, in between, in April, you'll have your first product ready, including that, both on the product development side and on the business side. What would you say might be your top priorities?
Top priority would be testing these systems in, so we are going to pilot it. So piloting these systems is our top priority in the next few months. And building so now what is happening is we are validating. So one is piloting, at the same time building the system. So from the product development phase, we have to build the product, which is stable and people can use it as it is. So the other aspect of it is the mindset of the people. So if you are coming up with a new tech, people are used to something, using the system. So we have to make our systems compliant in a way that people could just plug and play and replace their older systems. Otherwise, that becomes a challenge of say that they have to change their habits or how they used to use the to get habituated to the new systems. And that's what we don't want to do in the first phase at least. We want to make systems, the products which can directly go into the current existing systems and be complementary to that one. And secondly, when you say the business side is, if I were to sell you or sell anyone a washing machine in 1900s, you would not buy from us because the applications or the use cases were not there at that point in time. There are technologies which are a bit futuristic, and you have to first establish those use cases. You have to show people that these batteries are good for this, explain the value addition to them. So on the business side, there are no established use cases for these kind of batteries because these are one of its kind in the world. And we have to, in the business side, to explain it to people what it will be used for and what will be the value addition to you. One, we have to show it on paper, show it theoretically and then prove it on the ground. So those could be the business challenges, saying that how do I establish use cases for people and then show them what is the value addition to the existing systems.
That's it for today. You can find links to the bios of Gunjan, Akhil and Hamdan and Sthyr's website in the show notes. If you're an aspiring founder in India, especially in renewables tech, do look them up. I'll be back with another episode of Speciale Focus, and until then, it's goodbye from me, Hari Arakli. Thank you for joining us.